Okay.
So then I will just quickly, so we talk about the Lite client and the comments that are there on the PR, and most of the comments are just changes to the document which I implemented already, which I can. I mean, still don't know what is the right way to do. Put a new document on there and put a new PR, or what is this is the idea. But it was not. No, since everyone
you can just push a commit with the changes. Yeah.
Okay.
Push directly to the same branch. Yeah.
Okay, and the PR will okay. Good, I can do that. Then I think the major thing at this point that might change the document most is the comment by Ethan about whether we should start to have like directly in this specification communication to multiple full nodes in order to sort of have checks, and whether this should be done already here or not. And this I think we should discuss, because in principle, one point is we can sort of redundantly ask for headers from different full nodes to the cross checking. The question is, if we do this, how light the client stays if we do this, or whether this should be sort of sort of a similar protocol that sort of monitors what's going on the chain, rather than. So the question is whether the Lite client should be responsible for enforcing that everyone behaves correctly. But I mean, there are trade-offs to be taken. It's not so clear what.
What's the advantage of putting, I guess, implementation details to which full node the Lite client is communicating in the spec?
It's not implementation detail. I think it's actually fundamental here that the Lite client is capable of detecting conflict.
I see. So it's more like we are specifying some sort of fetch data and submit data functions the Lite client will call exactly on full nodes, and we'll specify properties those have to have in order for certain things to hold.
Yeah, because we typically try to be like, okay, well, the Lite client connects to one full node and it runs this protocol with one full node and blah, blah, blah. But in that, that thing's not going to be safe, because then it's not able to detect any conflicts or anything. So I think there's roughly like 3 components that are somewhat orthogonal to this whole problem that might help to kind of lay out the space. So one is basically the focus of Joseph's Joseph's write-up, which is really like, what does the Lite client need to verify to actually know that that it can move forward or not? So that's one. Another is, what does the Lite client have to do kind of more at the network level to make sure it can detect a potential conflict? Because if there's no one out there detecting conflicts, then nothing's going to get enforced. And then 3, what is the set of evidence that the full nodes must be able to process to ensure the guarantees for the Lite client are respected? And it's not necessarily the Lite client that has to, or that will even be capable of creating that evidence and understanding the evidence. All the Lite client really has to do is detect conflict. And to detect conflict, it needs to be trying to sync from at least, more than one full nodes, that it can be like, okay, there are conflicts here. And so that it's certainly going to open up performance challenges on the implementation side around, well, are we really going to go and verify the same set of signatures multiple times in parallel? And ideally, in a performant implementation, no. But initially, it might be worth we can have as we want, and then deal with like performance improvements by caching verification results or something a little bit later.
I see. Yeah, that makes sense. I suspect it might also be possible to offload a bit of work to honest full nodes, in the sense that if the Lite client sends some summarized data about what headers it knows about, and the full node can check, like by looking up past headers it knows about, whether there are any mismatches, and if there are mismatches, it tells the Lite client, and the Lite client sends the full signature set or something. Because we're already assuming honesty, so
that's true too. So instead of having, because I was kind of picturing it having like multiple, like a single Lite client consists of multiple like consumers, and each one is running like the Lite client protocol. But it might actually make sense to only have one such consumer and then have full nodes that you're notifying about what you've seen, and then they'll tell you if something is wrong, and then you give them, but that's not something that's currently exposed at like an RPC level, right? That would be like a different service that we would have to implement. So but that would certainly probably be a lot more efficient than like trying to download all the Lite client details from multiple folks. Yeah. But the point is that one way or another, we have to kind of capture this requirement a little more formally so that we know how it's going to work and so that we can kind of rely on it and so on.
Yeah, that's right. And there will be synchrony bounds on all of this, which is important to specify.
Exactly. Yeah. So it doesn't necessarily need to be, Joseph, it doesn't necessarily need to percolate through your write-up or change things that much, so long as it's kind of articulated at the top or something that there must be some way that this is happening, and that the write-up is simply describing, the single consumer state, what the Lite client has to do to jump ahead. And it's assumed that, via some other means that will also be specified that, something is happening. But then it just means that the write-up wouldn't be the full story, and we'd need to take into account that other piece, which,
Yeah. I mean, in some sense, right now also what's happening right now, we also detect, I don't know what precisely mean with conflicts, but sort of headers that don't match together right now, you also detect this, which might potentially, if you communicate with a faulty full node, they could stop you quite some time, right? Because they might ask, force you to ask for more and more headers, and only sort of at the very, very last point be very clever and sort of give you the conflict headers at the last. So this is sort of the worst thing that they can sort of do to you. But then the moment you have a conflict, so assuming that sort of on the chain itself everything is fine, then you know that the full node is faulty and you can submit all the headers that you have and out. But whether there are other issues and inconsistencies that come because we have to look at.
Well, do you mean that a full node could like waste a Lite client's time if a Lite client was trying to bisect by just returning like structurally valid headers but that contain no signatures from any validators and continuing doing that?
Yeah.
Like, is that right?
Yeah. I mean, in principle, if you even in any kind of mode, even if you want to do sequential, right? You talk to one full node and you have some old header and a new header, and you want to convert an old header from the new one, they could just give you something that looks consistent until the very end, and this is sort of one thing which I don't think you can actually. I mean, what you can do to spread this is sort of you ask for every header you ask a different full node for the header. That would sort of spread this danger a little bit. And this would for the current write-out, since right now I'm just invoking the commit, I'm not very specific on where I invoke where I ask for the header. When you just put in there just some,
yeah, that's true. I mean, the other thing is that, since this is sort of a statistical thing anyways, a Lite client which has reasonable surety that the validator set is unlikely to change drastically within the unbonding period, even if it's not guaranteed by the protocol, can start like switching full nodes if they're suspicious.
Yeah.
In case it's hard to switch every time or something.
Sorry, my cut out, so I missed a bunch of that. I heard something about the idea of like requesting different headers from different full nodes. I get.
So the point is that the biggest danger that you have right now is basically that the faulty full node could for a very long time block a Lite client, but just feeding consistently looking. And if you sort of spread this by saying I ask each header, I ask different full node to provide me for these headers, at least you might earlier figure out that something is wrong, right? I'm not going to Lite.
Yeah.
And this would not change the protocol too much, right? At the point where I ask for the header, we just have to sort of always take different nodes.
So what about another slight variation? The full node, the Lite client can tell the full node what header it knows about. And the full node can understand bisection. So it should be possible for the full node to just send back all the headers at once that the Lite client would need. And then the Lite client could like randomly select certain ones to check. Maybe that's less spammable by the full node. It would also be useful in the optimistic case where the full node is honest, just so you avoid all these network round trips.
You're saying the bisection what could happen instead of interactively, the full node could just deliver everything the Lite client's going to need because it knows what the bisection points are already.
Yeah, that's right.
That's interesting. And then you could just request that set of headers for multiple full nodes at the same time before you even start verifying any of them and see if they agree.
That's right. And you could verify, you could go a step even further and like randomly verify headers within that set. The full node doesn't know which you'll check first, and that prevents even more computational spam.
Right. Interesting.
I mean, I feel like that kind of concern, though, is a bit secondary relative to just the basic concerns about evidence submission.
Yeah.
So maybe we should focus on evidence submission first, anything that has to do with safety.
Yeah. That sounds good. So, it goes back to the question of like how to exhaustively cover all the kinds of things to punish for. And it feels like we're getting a little bit closer, but we still haven't really kind of written it down in a way that I think is fully convincing. But I don't know if anyone has yet thought of any kind of evidence besides, the flaws with like basically like forks or invalid state or counterfactual signing. And so far it seems like we actually do have to punish for all of those to actually secure the thing. And that, specifically the thing I found on Monday was that the counterfactual signing isn't enough and that we actually really do have to punish for invalid state. And that is somewhat unfortunate, but maybe not all that surprising.
Could you, why is it unfortunate? It's on the application state, or what's the word with the?
Well, just that it's unfortunate because it requires execution of the application to know that it's to know that the thing was wrong. But I guess it's not that dissimilar from counterfactual signing, where you have to know that someone wasn't in the validator set, which also requires execution from the application. So it's not that I don't think it's really different than that, actually. So it's not that big a deal, but because we kind of have to do that for the counterfactual signing anyway.
Okay.
But all this stuff is gonna percolate into IBC, and it's gonna be relevant to what happens there. So it just
at least in the sort of Lite client part.
Yeah. Right. So how should we proceed here?
I would just note that another separation we might want to make, at least at the algorithmic level, is which sorts of slashing are required only for bisection and which are required in all cases.
Right.
Because some people might want to implement Tendermint but not worry about bisection and simplify their lives.
Right.
So in the other document, which I also can commit into Sarko's branch, there I tried to classify different attacks and who the attacks are attacking. Sort of go from validators to full node to Lite clients with sequential and Lite clients with bisection.
So I don't think I understand the distinction you're making between validators and full nodes. Can you clarify what that is? As I understand it, the protocol or like Tendermint consensus is what full nodes run in full form. The only additional thing validators do is sign stuff. Is that right or wrong?
That's right.
That's right. But sort of the point is that if you assume a full node is sort of fooled to decide on the wrong block, and all the validators sort of sign the block correctly, the system might still go on. It's just the problem of this one full node that sort of it has been attacked, while sort of the system is still within the fail assumption. So it's, for me, it's, I think
that full node could have been a validator, right?
Yes, I mean, sort of the full nodes are a subset of the validators, but if you sort of manage to get two validators to decide on different blocks, then you are in a real problem, because then you actually have a fork, right? Then sort of they can also decide on different validator set, and sort of then it diverges. While if you
right. I guess, what are the cases where you could fool a full node but not a validator? Are there any?
I mean, in principle, if you have more than 1/3 of faults, they could just decide to fool a full node, but keep the chain running. You know, they can just perhaps lie to one guy and not the other.
No, I mean that if I am a full node versus if I am a validator, is there any situation where I would be fooled or could be fooled if I was a full node, but not if I was a validator? I don't understand like what cases that would be.
No, that does not make a difference from the attack viewpoint.
Right.
So you could, as attacker, decide to keep the validators together and going forward, but you know, divert one of the full nodes.
Oh, I see. So the game theory might be different.
But it's just, but the same attack you could also use for splitting the chain. But sort of there's a difference, I think, in the outcome of the.
Yeah, that makes sense. Okay, be helpful to clarify that, I think. Thanks.
But all this, also, it's also not super clear to me, right? Also because you could fool a full node, and then in the next iteration, this full node sort of becomes a validator. So what you do with a validator that is sort of acting on wrong data is the same kind of attack. This is not perfectly clear. I mean, these scenarios and all this, I think we should discuss in more detail.
Right. Yeah, I'm not sure it's really going to be helpful here to distinguish the full node from the validator.
Okay.
Because they're both effectively full nodes. And you know, we could parcel up the kinds of full nodes. Like there are full nodes that are validators, there are full nodes that are sentries for validators, there are full nodes that are seed nodes, there are full nodes run by this entity or that entity. But as far as this kind of these attacks are concerned, it's really just about what can you pull over their eyes. And in that respect, it's kind of all the same because they all do the same amount of validation.
I mean, the other thing which was not very clear to me is sort of what if you would do an attack where you sort of keep the validators together and run together, and sort of all other full nodes you convince of something else. Would this have impact on the gossip, for example? Would the system fall apart or not? This was not so clear.
Interesting. So basically you're saying all the validators somehow collude to sign something to trick the full nodes.
Or I guess a subset of validators with some amount of network control who can eclipse or isolate a full node could choose to fool it, but not the other validators.
Right. And then that could compromise the ability for the validators to continue to communicate because the full node will have the full nodes that are gossiping through could have diverged. I guess that's possible.
Yeah, I mean, it seems like if we're in that case, we're already in the case where there's a fork on the network or something, and so worse things than gossip divergence are possible.
Yeah, exactly.
I mean, perhaps it's even a good case, no? Because if the system stopped delivering messages,
yeah.
But all these things, I think it's I need someone to discuss these things who has a much better understanding of what's, how all these pieces are fitting together, I think. But
right. I guess I would lean towards treating the gossip protocol at the moment the sort of same way as we're considering treating the full node communication protocol from the perspective of the Lite client. There exist some gossip functions, and we state that they have some properties, but otherwise we don't analyze how they are implemented from the perspective of safety, at least at the moment.
Right.
Okay. I think we can see whether there's another question. I would like. Yeah, the other thing perhaps we could quickly discuss was this question also brought up by Ethan about this weird thing that for directly for adjacent headers we use this 2/3, and for if there is a hole we just use 1/3 on the first side. I mean, it's not that precisely, right? As you said, it's if you have two headers, one after the other, it's actually not checking any intersection because you're just sort of do the check for the headers.
Right.
But in the 1/3, you do an intersection. So one thing which I did not write explicitly, but after you wrote this question, I thought about a lot. So somehow what you have to make sure is that sort of all the header is sort of consistent. So this one correct guy we rely on must also somehow sign that the validator set of the new header is actually a proper one. So all this thing must fit together and must be consistent. So this is, I'm not sure whether all this I guess these checks are all there because everything is hashed and checked. But sort of the moment if you have this one correct guy you can rely on, and he signed that okay, this header has this validator set and all this is fine, then I think this one correct argument is sufficient.
Yeah, but he would be. I mean, he would be signing. So you're saying that's already there, or that's not there?
Guess it's there. I'm not sure. I'm not 100% sure, but I have to.
Okay.
So this is the argument that you need. But I guess everything is sort of
Because the header has a commit. The header commits to the validator set, and he's signing a hash of the header. So transitively
it's all there.
Signing a correct. You have a correct process signing off on what the validator set is.
Yeah. I think, and then if you have one correct process who signs the validator set, and you understand that you have 2/3 of this validator, and then I think everything is it's good.
Right.
Yeah.
I mean, the point also there is, this is also why we added here this trust level parameter, is so that we can also ask for 2/3 there. The point is just the observation we had in the last write-up, that if you ask for 2/3 and you have some changes in the validator set, it's less likely that this check is positive, and you most likely will always fall through the sequential code otherwise.
Right. So in practice, it seems the validator set changes relatively slowly. We don't actually have, big turnover. So that's promising for this. But.
Yeah. Another question I have, which is maybe slightly orthogonal, but is it possible, and would it make sense in some cases for the Lite client to use a threshold that is higher than 2/3, both for the sequential and the bisection case, in order to give up some of the liveness properties so it wouldn't succeed in tracking the actual consensus in some cases, but get additional safety?
So I think that's what Joseph was just saying, right?
Oh, okay.
Yeah, that you can basically parameterize it to require more than one correct process. It's basically a question of how many correct. I mean, sorry, it's not really good to talk in terms of number of correct processes because we're really talking about fraction of correct voting power. But you can parameterize it to basically require what fraction of voting power do you require to be correct, and I don't know what one corresponds to. It's really like slightly more than
1/3.
I guess, yeah. But it's not even because it's only it's slightly more than a third minus a third. It's epsilon, basically. It's just epsilon correct, right? So yeah, how much of that do you really want? That's the issue, yeah.
I'm not sure, Chris, did you say 1/3 or 2/3? Because 2/3 might be a little bit tricky because most likely Tendermint will always sort of collect 2/3. You must be quite lucky to get more than 2/3 messages for pre-commit and commit.
No, we do Tendermint waits to collect all the votes. Well, it doesn't wait to collect all of them, but it kind of builds in a mechanism to allow more than 2/3 to be collected. And so when you look at the Cosmos Hub, most of the blocks actually have commits from all the validators.
Okay, good. Then I understand the question.
Yeah, I think it is at least possible that there are some situations when that makes sense. If you have a super high value IBC connection or something, you might really want to trade liveness for safety and wait for 9/10 of commits, even though you realize that there's some chance that the chain will progress and you will not, because that case is easier to recover from than the case when, some fork happens.
Correct. Yeah, so higher safety thresholds. Definitely parameterizing it with respect to the fraction of correct voting power might make a lot of sense here. The other thing I was thinking when I was trying to model this was with respect to having this idea of having multiple consumers and consuming from, a single Lite client consumes from multiple full nodes in parallel. And within each connection, they may be verifying headers, but they don't necessarily trust those verified headers right away. So I was distinguishing between verification and trust, and basically having some kind of threshold or time-based arguments around the verified headers before they're considered trusted to facilitate. Because the problem is this scenario: a Lite client comes on and downloads a bunch of headers and trusts it, and then goes offline, right? And then now it has no capacity to find out that it might be wrong. And so if it literally only comes on, once every 3 weeks or whatever, in the middle of that period, syncs the first thing it sees and then goes offline, unless there is someone else being the fisherman, looking for issues, it's not gonna find anything. So, either it has to be coming online multiple times to explicitly look for conflict, or when it does come online, it has to explicitly connect to multiple nodes and not just verify the first thing. This kind of consideration is why I felt that the connecting to multiple nodes is so fundamental to the protocol and to be captured somehow. And so either, if we don't want to make any changes to the RPC, then we have to do something like this. If we do make changes to the RPC and it might really be worth it, then we have a few other options. But yeah, it seemed like that also might be more generalizable, especially not that we necessarily want that, but not want that yet, but to the to other blockchains that don't necessarily have the instant finality, where you actually would have some kind of time-based or node-based thresholds for deciding when to trust things, and therefore distinguishing things between something that's verified as valid and then something that's actually really trusted.
This reminds me also one thing I didn't write explicitly, sort of this expiration period, right? Even if you trust the header, 3 weeks later, sort of it's untrusted again, right?
Right.
This is sort of what you say. If you go to sleep for 3 weeks and you wake up, but sort of the point with time is sort of that you can locally decide, okay, I stop trusting this. My time is passed.
Yeah.
Right. I can also put a note in there about that, which also perhaps. Should we talk about the header bonding period also quickly, about the height-based one?
Sure.
Because also you had the question there. So I added a comment just, I don't know, an hour ago or so about these heights, and sort of the observation we had last week was that, so if you're a full node and you execute the protocol, then sort of height-based bonding period and trusting period works for you, and you can define the failure model because sort of you are in the system. The problem is if you're not in the system and you don't know what is sort of
the height,
the current height, it's problematic. So we could still, I think, define a Lite client, but we need an assumption which or some method to ask, give me the most recent height, and then you have some assumption about the most recent height and similar checks. But
or you make an assumption about correspondence of height progression and time progression, right? You just calculate from your local clock that at least X blocks will have passed.
Yeah.
But then what's the point of the height-based mechanism?
Yeah, nothing. It doesn't matter.
So why even bother with it? It seems like we have to actually fix the proposer time thing.
I still think it doesn't allow the Lite client to make more assumptions about what headers it can trust, but it still provides some insurance against equivocation attacks that also rely on attacking the timestamping protocol. Right. If BFT time is somehow less secure or differently secure than usual consensus, which agrees on heights, there might be reason to do it still.
I see. Okay, it'd be worth fleshing that out more, because the original problem with the current time system is that more than a third can arbitrarily move the time forward and not be punished, and therefore exceed the trusting period very quickly and mess with Lite clients. So if we put heights in there, then I guess the point is they'd still be punishable by full nodes, but I need to think through that more. I don't fully get the distinctions, but
so in theory, clock synchronization and consensus both need 3F+1 in the Byzantine case, which is the good news, I guess. So we should be able to get BFT time as reliable as consensus.
Well, we do. The problem is around accountability, right? Like currently, the BFT time, has the same thresholds as consensus, but the consensus is accountable up to 2/3, and the BFT is not. The time is not, right? Because we're using the medians. If more than a third move the clock arbitrarily into the future, there's no way to really know
in protocol
that was incorrect.
I agree. So I don't say that the current solution is the best one, but
right.
Also, yeah.
Right. So yeah. Okay. Well, we should try to. It's probably worth trying to understand if the hybrid height thing really gets us what we need or not, so that we don't waste time engineering it if it doesn't theoretically solve the problems.
On chain it might help, perhaps, I don't know, but for the Lite client, even then it becomes sort of complicated, because even if you ask for the most recent height, right, sort of you rely on the fact that the messages that you receive are recent. So from a theoretical viewpoint, you would have to put a certain assumption on the messages in order to actually be able to use it somehow, I guess. Because if you ask for the most recent header and it takes 2 years to get an answer, then also sort of you're lost.
Yeah.
From this viewpoint, I think without using time for the Lite client, it's not so clear whether you can do it.
Yeah, well, so my impression is that the Lite client will definitely need to use the time, that the Lite client can't really do anything about the height, but having the height as part of the unbonding period in the chain might prevent this attack where more than a third moves the time arbitrarily forward, but they're still liable to be slashed, right? So as long as their accountability is still based on the height, then even if the Lite client can't do anything about the height or use it in its own local calculations, at least if it detects conflict within a local reasonable trusting period, the validators that tried to fool it would still be slashable. So if we can work that out and show that that's basically the case, then that might be okay. That might work out. Yeah.
Yeah.
It probably still wouldn't be as good or as strong as having, a 2/3 requirement on the time. But, doing that, so far the only way we know how to do that is to let the proposer do it. And then it creates, weird potential liveness issues that would also be, interesting, certainly interesting to pursue, but potentially a rabbit hole. And yeah.
I just kind of have a question just overall with the Lite client. Um, this is under the assumption that you have a consistent block time. So if Tendermint becomes more event-driven, just kind of create empty blocks false, and then the discrepancy between block times is, let's say, pretty great, would that affect the current spec of the Lite client?
The current one, no. If we incorporate this height stuff, then potentially yes, and it would probably require some minimum block production. So the no empty blocks feature allows you to say that only produce blocks if there's transactions or you've waited 30 seconds or 2 minutes or whatever it might be. So you can have some. So it lets you set some lower bound on how many blocks should be produced, and that's the kind of thing that this hybrid approach would have to rely on.
Well, even if we do just time, we have some requirement like that, right? Otherwise, you could have more than an on-bonding period pass between two subsequent blocks.
Right. I mean, we're already assuming that blocks are coming rapidly, with some frequency. Yeah. Okay. So yeah.
Should we call it for this recording, and then it gives us a good spot to leave off on, and then once the updated Lite client spec gets pushed to GitHub, then we can review further, and then once Anka and Zarko are back, they can also catch up.
Sure. Yeah. Should we discuss any kind of next steps for the upcoming week before they're back, or just it's kind of straightforward to address comments and just like clarify?
So I think the goal would be to, because the Lite client is currently blocking other things like a secure state sync. So the spec, and then I'm not sure how relevant the ADR from Zaki is. So we would need to update that if need be, or merge that, and then finalize the spec, hopefully in the coming week or two.
Okay.
I think there are a lot of unaddressed comments on the ADR. I don't know if Zaki plans to take that on or not.
Okay. Are there any open issues on the sequential Lite client, or it seems we pretty much have it down. I guess there's still a question around, how can we prove to ourselves what kind of evidence we need, and that it's only the double signing style thing, and not we don't have to worry about invalid and so on.
Yeah, I mean, some of the fork accountability stuff we might still want, right?
Yes, I think we need the fork accountability stuff what we've been calling equivocation and now amnesia. Yeah. But
we don't need counterfactual slashing or invalid state.
That's my understanding for the sequential. Yeah. So, and for amnesia, just to be clear, we can't actually capture that in real time. It requires like the fork accountability protocol to be entered into, which would typically only happen after a fork has occurred. So that that's something to keep in mind, that if I was an attacker and I was trying to mount one of these attacks, I would try to do it using the amnesia attack, because then even if I fail, I won't get punished, right? Whereas if I'm trying to do it through equivocation directly, then if I fail to get my 1/3, everyone will get punished. So you could extend that and then say, well, why even bother punishing for the equivocation in protocol? Or it's like, why punish one and not both? And right now it's basically just a matter of like protocol complexity. But it bothers me sometimes that that's the case. Yeah. Anyways, so perhaps in the future it's worth thinking about whether the amnesia attacks can be caught in real time, punished in real time. This is actually relevant to the. I learned yesterday that people are using the KMS with multiple validators, a single KMS with multiple validators for high availability. And this is probably one of the worst ideas I've ever heard in my life, because this could easily result, maybe not easily, but this could, if enough validators are doing this could result in a fork of the blockchain that because of this amnesia attack. So they could all accidentally commit amnesia attacks, and then we end up with a fork. And then, more than a third of them are suddenly deemed to be malicious and get forked out of the blockchain. And it could all just happen by accident. So, if you're watching this video and you're doing this, please.
Isn't it the case that I don't know, because I don't do this, I agree with you, but in HA mode, doesn't the KMS software itself track the hidden round?
Yeah, but the KMS can't prevent the amnesia attack. It suffers from the same issue, right? For the same reason that we can't punish it in protocol, the KMS can't. I mean, unless way more information goes over the KMS, right? Like it can prevent in-round double signing, what we call, I guess, equivocation, right? But it can't prevent you from pre-voting in a new round after you pre-committed something else in a previous round.
Oh, yeah, I guess it probably doesn't do you right. It could. It seems like it wouldn't be. It's tracking all the signatures. So I don't know why it would be super hard to track that too.
It could. Yeah, but then it needs to know, it would need to, like, in order to allow you to change, like in order to be able to unlock, it would have to know that you saw.
Yeah, okay.
Right? So, yeah. So that's really tough. And so unless we make changes to the protocol to actually facilitate detecting this thing in protocol and punishing it in protocol, which maybe we want to do ultimately, it's not really safe to do that with the KMS without doing a lot more work. So, something to keep in mind. I mean, it's interesting how all these problems kind of intersect in various ways in the system. But yeah.
I would repeat your statement and post it somewhere in Twitter so everyone that is doing that knows that it should be.
Yeah, I don't think that was clearly communicated. The KMS states that it handles double signing prevention. And even though at the moment we don't punish for this case, it's clearly something that validators should be concerned about.
Yeah, we could accidentally fork.
It's kind of similar to what happened to inclusion, I think yesterday or the day before, with they had different votes, and they what was it? KMS 6.1 had a bug in it.
So I don't think they were doing this multiple validators, single KMS thing, but they were trying to basically, I think they were making changes to better support that, and it resulted in an uncaught panic or something, which is what took them down, as far as I understand. But yeah.
Yeah, I think at least from my side, the important message is that the KMS and that check should be kind of a safety net, not kind of the thing that everyone relies
on. Yeah, that's right. I mean, I think it would be super cool to see this kind of fuck up happen. Like if the network accidentally forked because people are abusing the software, like it's a great lesson for everyone to learn. But
I don't know. I agree. I mean, I just think high availability replicated keys are the wrong design direction. Like one design direction is to add more validators. Another design direction is to do something multi-party where you shard your key.
That's right. That's what I'm
run Tendermint validation.
In favor of using the cryptography to do this. Yeah, exactly. Yeah, that's right. So we on a separate note from a product perspective, we may want to prioritize supporting multi-sig public keys for validators so that we can put this to bed.
Yeah, I think KZen is the most production-ready has the most production-ready implementation of sharded ECDSA. So we could look at that. They're using it for wallets, like multi-signature wallets, but it should be adaptable for validators. You need low latency between the shards, but most validators have that.
Right.
I also think Unbound Tech from Israel has a similar solution.
There must be some like research center for multi-party.
Right. But these are all like pretty advanced. Like as far as I know, the Unbound is using like multi-party computation or something.
Yes, they're advanced. So
that's all excessive. Like let's just do normal multi-sig, right?
But that requires extra bandwidth on the Lite client's behalf, right?
Yeah, it'll double the signature size. Yeah. So that's not great. But we're about to cut the commit size by 80% or something. So it's a good time.
I see.
Fill it up with something else, right?
Anyways, these are kind of extraneous product design conversations, but yeah, from the sequential Lite client thing, yeah. So the fork accountability document was really helpful, and it really relates here. There was that so-called back to the past attack, but my understanding of that was that that's actually common to everything and isn't really a distinct attack. It's just like a way an attack is mounted. And so really what we're dealing with are, it'd be nice to actually be able to lay this out formally so that we could be certain that we're exhaustive. But I think we're basically there with respect to forking the blockchain, invalid state, and signing when you're not a validator, and those being really the only kind of attacks. With signing when you're not a validator is kind of captured under invalid state. You just have to look out for it explicitly. But it'd be really nice if we could lay out the problem of validator set membership, basically. And
ideally we could have a Lite client algorithm and a full node algorithm in terms of basically just what's in the Tendermint paper, and then some equivalent thing for a Lite client, and run through exhaustively all of the cases when the Lite client accepts and ensure that they are either valid or accountable and slashed for.
Yeah, exactly.
I guess the easiest way to do that at this point may be just to try to write a Lite client algorithm with these things in mind and then run through that.
Right. Okay. Okay, so I guess as far as next steps here, the main thing is kind of addressing the comments on the existing PRs and kind of cleaning that up and consolidating them. It's not, I wasn't sure exactly on their existence as distinct documents versus whether they'll become part of the same kind of thing.
I think we should just merge it into one PR.
Sure.
We went from I think 3 PRs to 2 PRs, and now we're back to 3 PRs. So we can merge the fork accountability and the Lite client spec. The ADR, I'll try and touch base with Zaki to see. If not, then someone from on this call may have to take lead on it.
Right. Okay.
So, what is the situation now with the fork accountabilities? Has someone worked on that, or should I look at the comments and incorporate them, or
on the PR with Sarko's doc?
Yeah.
It, I think, has some comments that may be subsumed mostly by what we talked about here, but are still worth reading.
But then I will just go through them and incorporate them into my write-up, and will then also push that one.
Yeah. So they are kind of addressing, if I laid out those like 3 axes of the Lite client, they are kind of 2 of them in some sense, right? Like Joseph, what you've been writing is like, okay, how to verify. And then the Jarko PR is more like, what are the different kinds of evidence? And then, we'd have some other description of how to actually detect, how the Lite client should be expected to detect conflict. And together, those 3 pieces will, compose the entire Lite client specification, I guess. Yeah. But it sounds like there's just some cleanup work to do on the documentation and presentation. So, yeah.
I just want to be sure that we are not crossing our paths or something. So
right. Well, I don't think anyone is working on the fork accountability stuff since Jarko's been on vacation. But a bunch of people.
I've been working, but I haven't pushed anything yet because I was not aware that the discussion.
Oh, okay.
One because I thought.
Okay, great. Yeah.
I will look at this and then incorporate what I just did. I sort of tried to make all these cases a little bit more distinct and make the execution, the example executions, the scenarios more clear.
Right.
Also,
that's great.
With Igor, it's not a short-term thingy, but what I would like to see whether we can sort of use our verification tools to understand whether sort of the scenarios that we have identified are exhaustive, or whether we can sort of find some, sort of look for counterexamples that do not measure any scenarios.
Yeah,
it would be very interesting, sort of, especially if we are targeting solutions that go for scenarios, to understand how complete the scenarios are.
Yeah.
Yeah,
That would be incredible. Yeah.
Good.
Awesome. Okay, guys, I think that was good. So maybe, I know Jacques was not really back till Friday, but maybe we'll be able to do something Thursday. I'll check in with Anka too. But otherwise, I guess we'll see you on Monday.
Just one other thing doesn't have to be in the recording, but on Monday, we talked about the Preval JSON. Just if there was an update